Okay, in this video we're going to take a look at a couple of applications of quadratic functions, basically word problems. So here's the first one. So, first example, what is the maximum area you can fence with 1,200 meters of fencing if one side of a rectangular area is bounded by a river? And I approach these with a four-step approach. The first one is to define your variables, and sometimes defining the variables is easiest to do by drawing a picture. So here's my river. And my fencing is going to go in a rectangle, essentially a rectangle. So these sides are going to be equal to each other, but I'm not going to fence along the river. So I don't know how far this is, but this is the same distance, so there's a variable. And I don't know how far this one is. If I use a variable like y, a second variable, to work with on my picture, that's okay, but my equation needs to only have one variable in it. So my second step, which will be to design an equation, it has to be in one variable. So area is, for a rectangle, length times width, in this case x times y, but I'm not allowed to have these two different variables. So I have to somehow adapt this. Well, I do know that I've got x and y and x worth of fence, x and y and x, and that has to add up to 1,200. So what's y worth? Well, subtract away those two x's, it's 1,200 take away 2x, and so that's what this y over here is also worth. So my area formula can be x times 1,200 take away 2x, and there's an equation that I can use. It's a quadratic, it'll have x squareds in it, so I know that I'm on the right track. And now that I have that equation, I can go on to step 3, which is to find the maximum, in this case sometimes minimum, and I do that by finding out where the vertex is. So since I've got a parabola, the parabola is either upward facing, and it would have a minimum, or downward facing, and it would have a maximum. And there's three different ways that I can take an equation like a equals x times 1,200 minus 2x and find that vertex. Option 1 is to complete the square. So I'm going to multiply this through. I'll get negative 2x squared plus 1,200x, and if I factor out this negative 2, I get this. Take half of this value, which is 300, and square that, so I need to add 90,000, and in here I added 90,000. That's really subtracting, so I have to add subtracting 180,000, so I have to add 180,000 out here, and then I complete the square by getting x plus 300 squared, x minus 300 squared plus 180,000, and my x would be 300. And that's what I want. There is one of my variables, and I could move on from here. A second option is to just use the vertex formula. And the vertex formula is the vertex will be at minus b over 2a, comma c minus b squared over 4a. And I just need to make sure that this is in the form ax squared plus bx plus c. So there's my variables. I put them in, so negative 1,200 over 2 times negative 2, 0 minus 1,200 squared over 4 times negative 2, and I end up with 300 and 180,000. Okay? And my third option is to use the graphing calculator. Graph y equals minus 2x squared plus 1,200x, and find the vertex, which is done by finding a maximum or minimum depending if it's an upward or downward facing parabola. Let me show you how to do it on the graphing calculator. So in the graphing calculator, the first thing we want to do is go into y equals and enter in our equation, and then graph it. Now if I just hit graph, it's going to go to whatever window settings it wants, so maybe we should think through the window settings. The x value is the width of the fence, so the width of the fence is maybe, well, it can't be negative, and it could use up all the fence, I guess, which is 1,200 meters. And then y is not the y direction that we had before. Y is the area formula, so the area is not going to be negative, so make y0 y min 0, but it's going to be pretty big, maybe even like, I don't know, 500,000. It could be quite a large number. And so and same with the scale, and this is something that you just get with experience and trial and error. We want to make sure that when we hit this graph button, we actually get the shape of the parabola. So you can see in the x direction I went too far, and in the y direction I went a little bit too far. That's fine. There's a neat little trick using the zoom feature where you can zoom, choose number 1 box, and you can say, okay, well, how about I just need this part here, and just hold these arrow keys down, and this will be the new window setting. And so it'll change all the settings for the window, and now we see what the graph really looks like. And I want to know where this top point is, so calculate, second calculate, and it was a maximum, so number 4, and go to the left a little bit of where you want. You'll see there's a little arrow there. Go to the right, hit enter, and then it says guess, so I guess it's about right there. And use some calculus actually to figure it out, and it says x is 300 in a little bit because there's a little margin of error in the calculator, but it is exactly 300 with a area of 180,000. Okay, in any of those ways we come to step 4, which is to answer the question. And in this case we find that the maximum area occurs when the dimensions are, well, remember our picture, we had x and y and a river, and so I had 300 as my x, 300 meters, and the value for y was 1,200. Take away 2 times 300, which is 600 meters. And that'll give you a grand total for the area of 180,000 meters squared. Okay, let's take a look at one more example. Okay, so a school dance charges $15 a ticket, and at that price 250 people will attend. For each dollar increase that you make your tickets, less people, in this case 20 less people, will attend. So what should the ticket price be to maximize the total amount of money that the dance committee or the school or grad committee, whoever's putting this on, make? First of all, let's define what I mean by revenue. Revenue is how much each ticket costs times the number of tickets that you sell. So right now they're making $15 a ticket and 250 people attend, which is $3,750, but possibly they could be making some more money. So let's go on and define our variables, and we'll use x to represent a $1 ticket increase. So x is the number, and that's important, the number of $1 ticket increases. So 15 plus $1, 15 plus $2, 15 plus x dollars. That'll be the new ticket price. And then the number of people who attend will go down for each of these increases. And so the number of people who attend, well, it was 250 people, but every time I increase the ticket by $1 whole, I will lose 20 people. So I'll lose 20 people once or twice or 3 times. I'll lose them X number of times. So for example, if I increase it to $18, I will lose 60 people. Okay, now let's take a look at our revenue statement again. Well, it's the cost per ticket, which is 15 plus x, times the number of tickets sold, which is 250 minus 20x, and I've got step 2, which is design my equation. So now I have to solve that. I have to go and maximize this equation. And to do that I have 3 options. I can complete the square, I can use the vertex formula, or I can use a graph to show it. I'm going to take option 2 and just use the vertex formula, which is minus b over 2a and c minus b squared over 4a. It means I need to expand this out, so I get 3750 plus 250x minus 300x minus 20x squared. Put it into the order of ax squared plus bx and plus c, and substitute my numbers in, so negative 50 will be positive 50 over 2 times negative 20, and 3750 is my c value, minus 50, it's actually negative 50 squared, and 4 times negative 20, lots of negatives in there. Be careful on these calculations. By the way, make sure you can do these calculations, so actually grab a calculator and make sure that I am correct, and I end up with this vertex. And so this number here is telling you you need to lower your ticket prices, not raise them, lower your ticket prices by $1.25. So they were 15, so I need to go down to $13.75, and that'll maximize the revenue, and you'll actually make $3,781.25, which it's not a lot more money, $31 more, but it is more money than you were making before. And students will actually, more students will come, and each student will actually pay a little bit less, which is a good thing as well. You can do this graphically as well. You can choose which way to do it. Okay, that's it for today.